Hello everyone, my dear listeners, students, anybody who trying to learn programming, Python language. Today it's our 13th lesson, the last lesson on Python fundamentals. So we're going to finish today all the basic skills you need, and very soon, probably tomorrow, we start another more advanced Python course. It's called OOP, Python Object Oriented Programming. Anyway, the last topic is two-dimensional lists. Of course, we need lists all the time, and you can picture list as a linear sequence of variables where each variable has an index, position, offset, whatever you call it. By the way, sometimes in some computer languages like C++, for example, they call it vector, one-dimension data container. However, the other task is also super popular. We need to handle table-like data structures. Why Excel is so popular between us? Because Excel helps us to somehow process data in rows, in columns. So, of course, Python has a tool to do that, and this is two-dimensional lists. In order to make it shorter, I'm going to call it 2D list. So, 2D list is where each variable has two positions, row number and column number. You see on my screen how 2D list can be viewed, can be pictured. So in an ordinary list, we have square brackets, an index to identify a variable, but in a 2D list, we're gonna need two indexes, two pairs of square brackets to identify an item in a list. Let's go to now the examples. So the main idea you have to understand, 2D list is a list of lists. So you can, in Python, embed containers. So any element of a container can be in turn another container. So I'm trying to define here a list for rows and three columns. So that's my list or my table dimensions. And you see my list is actually four one-dimension lists. So one list, it's a first row. Second list is a second row. And that's how 2D list is organized. But again, don't forget, we always start from 0. So this is row number 0. This is row number 1. This is row number 2, and this is row number 4. Columns also numbered from 0 from the left to the right. So this is column 0, this is column 1, and this is column 2. What I'm trying to demonstrate here is I can use the name of the 2D list without any square brackets. Quite interesting. Line 5. If you use it like this, you mean the whole thing, the whole 2D list. And I can print it, by the way. If I'm providing just one pair of square brackets, I mean one row. So in line 6, what I mean is this. Finally, if I provide two pairs of square brackets, which is most likely, most of the time, yes, of course, we need to identify a concrete item in a table, then yes, I provide row number and then I provide column number. So very common mistake. And it's, by the way, sometimes very hard to find if you put it the other way around, if you mean column first and row after. So don't, please. Always, when you address the 2D list items, first comes row. The column comes after. So that's the row number, that's the column number. Okay, so let's see what happens. Let's run this program. Oh, I am not supposed to put comments if I use a continuation backslash character, so that was my fault. Sorry, I have to open it again. My program. Okay, so one more time. I'm gonna remove this, that's my mistake. And now it should be fine. So let me save the changes. And what I expect, before you run, always try to understand what you expect. So you will, or you may, compare your expectations and the actual program behavior. So in line 5, I expect the whole list to be printed, everything. In line 6, I expect just this to be printed. And in line 7, I expect this. This, the last one, going to be printed. Why? Because this is row number 3, and this is column number 2. Let's prove it. Let's run it. And yes, you see that's precisely what I anticipated. Good. Now, this technique I showed you, creating lists technique, when you immediately initialize it, probably good for, let's say, not very big lists. But if my list is 1000 or 100 rows and columns, I can show you another approach. So you can use asterisk and you can use initializer. So here I initialize one row and then I initialize 11 rows. So basically this is a technique to create very big lists, 2D lists. And let me show you if it's working. Yes, you see all the rows and all the columns initialized with the same number, 0.1. Wonderful. Now let's take a look at the looping, because containers and loops are always related. How would you process such a big item, such a big thing as a 2D list if there is no loops? And what I see here, I got 3 rows, 4 columns, 2D list, lines 1 to 4. I printed before processing, and then I process in a loop. The more natural loop for lists and 2D list is, of course, for loop. So first step, I calculate how many rows in my list. You see, I am using it as it is without square brackets. Then I calculate how many columns in one row. I take the first row, but all the rows are the same. So I calculate basically here dimensions of my list. And then I start looping. I loop through the rows. Inside, I'm looping through the columns. And I increment each item by 1. And I print my 2D list after. So let's prove it. Let's see if it's working. And yes, you see my nested for loop is working fine. I modified my 2D list, so in order to go through 2D list, you have to nest one for loop into another for loop. Very interesting thing in Python, it is jagged list. So jag means not rectangular. So let me show you a picture so you can understand what I'm talking about. Jagged list. So what I'm talking about is this. So your 2D list may not look like a rectangle. You see an example. One row is 4 items. Second row is only 3. The third one 5. So we call this list jagged. And yes, you can still create such 2D lists and you can still process them. So let me show you again nested loop to process jagged list. So let's insert before and after messages. And what happens now, it's quite similar to my previous code, but there is an important change. So yes, I can calculate rows before I start the list, but I cannot calculate columns because they are different for different rows. So when I start my for loop by rows, I calculate for each row different number of columns, and then I'm looping through them. So I'm incrementing items by one in order to prove my jagged 2D list looping is working. I'm gonna print after. So let's save the changes. Let's run it. And yes, you clearly see the 2D list is not rectangular. It is jagged. And you see, I went through all the values, despite of the fact it's kind of, let's say, more peculiar. But I did it, and I managed to increment all the items in a jagged list by one. So this is the end of the Python fundamentals. In 13 lessons, I covered basically all the essential skills you need to proceed. I try to make my course concise, short. I don't explain stuff you may learn yourself. So this is very important. Stuff students can understand themselves. I don't have to explain. My task is to give you the first impulse, the encourage you. So please support the channel. I need your likes, I need your comments, and come to my classroom again, because a new course, Python Object-Oriented Programming, is about to start. So I'm gonna start it most likely tomorrow. So keep watching, please. Keep learning. More interesting, more advanced stuff is coming. All the best to you guys. Bye-bye.